Dear students, in our last lecture we have studied how to solve the homogeneous differential equation. Homogeneous differential equation means the terms having the same degree. That differential equation is called as homogeneous differential equation. Degree of the every term must be same. Now here from the exercise 8.4, today we are going to solve the differential equation which is homogeneous differential equation given to you. That is, see here, x square y into dx minus x cube plus y cube dy is equal to 0. Now if you observe here, then the degree of x square y is 3 because the index of x is 2 and index of y is 1. So 2 plus 1, that is called as degree of that particular term. So here the degree of x square y is 3. Similarly, degree of x cube is 3 and degree of y cube is also 3. So this is the homogeneous differential equation of degree 3. Okay, so first of all I will write the given differential equation given. So x square y dx minus x cube plus y cube dy is equal to 0 is homogeneous differential equation of degree 3. Now let us solve this. Now you know the procedure. First of all we have to rearrange this given differential equation in the form of dy by dx is equal to. So see here, I will write the steps. So x square y dx is equal to x cube plus y cube dy. Okay, now what will you get from here? I will express this in the form of dy by dx. Then what is dy by dx here? If you observe this carefully, then it will be x square y upon x cube plus y cube. So this is the important step that we have to follow always. Whenever you have the homogeneous differential equation, convert it into in the form of dy by dx is equal to like this. So say this is equation number 1. Now if you convert it into dy by dx, then to solve this differential equation we have to substitute the value of y is equal to vx. So this is the procedure given to you. So always to solve the homogeneous differential equation and after converting it into dy by dx, we have to put y is equal to vx. That implies dy by dx is equal to v plus x dv by dx, like this. So we have to replace the corresponding terms here to solve this differential equation. Now see, after this substitution what will you get? So equation number 1 becomes, see here, I will put the all values here. Hence equation number 1 becomes v plus x dv by dx is equal to x square into vx upon x cube plus vx cube. In place of y we will put vx and in place of dy by dx we will put v plus x dv by dx. Now simplify this. See what will you get after this. Here we get v into x cube divided by x cube plus v cube into x cube, and then try to simplify this if it is possible. Here x cube is common from the numerator and denominator and hence it will get cancelled. So you will get v upon 1 plus v cube, and here the left hand side is v plus x dv by dx. Okay, so the substitution is completed. Now just we have to rearrange this in the form of variable separable form. So for that I will write x into dv by dx is equal to v upon 1 plus v cube minus v, and hence we get v. After cross multiplication we will get, see the terms here, multiply by minus v, and hence we get this term upon 1 plus v cube. So hence we get minus v raised to 4 upon 1 plus v cube. Okay, now after this step we have to separate the terms of v and x. Okay, so see here the next step I will write here So as we get x into dv by dx is equal to minus v raised to 4 upon 1 plus v cube. I will transfer this minus v raised to 4 upon 1 plus v cube to the left hand side. So it will be 1 plus v cube upon v raised to 4 dv is equal to minus of 1 upon x dx. So see this step carefully, and this is the variable separable form. Now after getting this form, we have to integrate both sides. So integrating we get, see the step carefully, what will you get? Here we will get 1 plus v cube upon v raised to 4 dv is equal to, here minus as it is, into integration of 1 upon x dx. Okay, so integrating both sides we get this step. Now how will you integrate this? So let us see. Here it is 1 plus v cube upon v raised to 4. If you take the separate denominator, then I will write here it is 1 upon v raised to 4 dv plus v cube upon v raised to 4 means 1 upon v dv is equal to minus of integration 1 upon x dx. And after separating the denominator of the LHS, now it will be ready for the integration. So we get, it is 1 upon v raised to 4 can be written as v raised to minus 4 dv plus this is integration of 1 upon v dv is equal to minus of integration 1 upon x dx. Okay. Now what is the integration of v raised to minus 4? By the rule it will be v raised to minus 3 upon minus 3. See, here I have used x raised to n. Integration of x raised to n is x raised to n plus 1 upon n plus 1. Like that, here we get v raised to minus 3 upon minus 3 plus integration of 1 upon v is log of modulus of v is equal to, now on the right hand side it is minus, and integration of 1 upon x will be log of modulus of x. And I have to write the constant here as constant, suppose c1. Okay, then we will arrange that constant, but before that you have to write it as suppose c1. Okay, now to the next step I will adjust the terms like this. So minus 1 upon 3 into, this is 1 upon v cube plus log of modulus of v is equal to minus log of modulus of x plus constant is c1. Now I will resubstitute the value of v here, as our substitution is y is equal to vx, so v will be y upon x. So here if you put that, then we get minus 1 upon 3 into 1 upon, in place of v I will put y upon x, so it will be y upon x raised to 3 plus here we get log of modulus of y upon x is equal to, here it is log of modulus of x plus constant is c1. Now further if you simplify this, then we can write it as minus 1 upon 3 into, this can be written as x cube upon y cube, x cube upon y cube plus, now here log of y upon x means log of modulus of y minus log of modulus of x is equal to minus log of modulus of x plus c1. Now if you observe here carefully, then after this substitution, this minus log of modulus of x and this one is minus log of modulus of x will get cancelled, and hence after this what will you get? See here, minus of x cube upon 3y cube plus log of modulus of y is equal to, you will get the constant as c1. Okay, and further if you want to write this constant as log c, then what will you get? Minus x cube upon 3y cube plus log of modulus of y. If I write this constant c1 as log c, just for simplification, otherwise no need to write, you can keep this as a final general solution, no problem. but if you want to simplify, then you can write like this. Now we will modify the term here. I will write log of modulus of y minus log c here is equal to, transfer this minus term to the right hand side, then we get x cube upon 3 into y cube. Now after getting this, I will write log of modulus of y minus log of modulus of c can be written as log of modulus of y upon c. Y upon c is equal to x cube upon 3y cube, and I will keep this as a final general solution of the given differential equation. But remember, if you don't want to write the constant as log of modulus of c, then it is not necessary. You can keep this as a final answer, no problem. Okay, just to resubstitute the value there and write the solution as the general solution of the given differential equation. If you want to simplify further, then just you choose the constant as log c, otherwise it is not necessary. Okay, now let us solve another differential equation, that is homogeneous differential equation. Now if you observe here, then the degree of x into y is 2, degree of x square is 2, and degree of y square is also 2. So this is the homogeneous differential equation of degree 2. Now let us solve this. So first of all, I will write the given equation, that is xy into dy by dx is equal to x square plus 2y square. Now first of all, as per our procedure, I will write it in the form of dy by dx is equal to. Now it is very easy, just you transfer this xy to the right hand side, then you will get x square plus 2y square upon xy. So say this is equation number 1. Now to solve this differential equation, we have to put y is equal to vx. So put y is equal to vx, that implies dy by dx is equal to v plus x into dv by dx. This is by product rule, v into x. Derivative of v into x is v plus x into dv by dx. Now so hence we get equation number 1 becomes so equation number 1 becomes v plus x dv by dx is equal to x square plus 2 times vx bracket square upon x into vx. Now just to simplify here, from the numerator you will get x square common. If you observe this carefully, then in bracket it will be 1 plus 2v square. Okay, and from the denominator there is also x square, so x square into v. So that both x square will get cancelled, and hence you will get 1 plus 2v square upon v, and left hand side is v plus x dv by dx. Okay, now after this substitution and getting this expression, now we have to use the variable separable method. So x into dv by dx is equal to, just you transfer that v to the right hand side, and hence you will get 1 plus 2v square upon v minus v, and then cross multiply this, then you will get 1 plus 2v square minus v square upon v. Okay, so further you will get 1 plus v square upon v. Now try to get the variable separable form, that's why I will transfer this 1 plus v square upon v to the left hand side. It becomes v upon 1 plus v square into dv is equal to, I will write x upon dx to the right hand side, so it will become 1 upon x into dx. So this is the variable separable form. Now after getting this, you have to integrate this both sides. So integration of v upon 1 plus v square dv is equal to integration of 1 upon x dx. Now the integration is very easy, because if you adjust here 2v to the numerator, because the derivative of 1 plus v square is 2v, so I will write 1 by 2 into integration of 2v upon 1 plus v square dv is equal to integration of 1 upon x dx, because after this adjustment it will convert it into the form of f dash x upon f of x here, because it is 2v upon 1 plus v square. So that's why we get the integration as 1 upon 2 into log of modulus of 1 plus v square is equal to, here it will be log of modulus of x. Now both sides contain the log, so I will write the constant as log of modulus of c here for further adjustment. Now here I will write log of 1 plus v square raised to 1 by 2. Okay, and here it is log of modulus of x into c by logarithmic rule. Okay, now comparing both sides, we get 1 plus v square raised to 1 by 2 is equal to x into c. Now further resubstitute value of v as y upon x. All of you know that. So we can write 1 plus y square upon x square raised to 1 by 2 is equal to x into c. Now if you take the square on both sides for the simplification, then we get it is 1 plus y square upon x square is equal to x square into, it is actually c square, but you can write it as c only because it is the arbitrary constant, so no need to take the square of that. Now by cross multiplying left hand side, we get x square plus y square upon x square is equal to x square into c. Okay, and you can keep this as a final general solution. So this will be a general solution of the given differential equation. Okay, no need to write the square of c here, remember, because c is the arbitrary constant. So after squaring both sides, just you square the terms of left hand side and the right hand side's x. No need to take the square of c. You can keep this as a final answer. So this is the general solution of the given homogeneous differential equation. So try to solve this type of questions. Okay, see here carefully procedure. Okay, thank you.